Here's a little delve into the theory of relativity, period. So, we're back into the early 80s. I've gotten out of the service. I'm going to a community college. No, where was I? It was after that. Time flies. No, I was actually an engineer somewhere else. So it was even after college, this opportunity, it was because of college, the opportunity came up. So I'm engineering away somewhere else. I've got a good paycheck, challenging, stable job, 3 hours a day of driving to and from work, and life is good, right? But a local university has an incubator program to help small companies get started. And I'm curious, George, and had other ways of hearing about some of these things going on. Company began making equipment just in the engineering phase to draw something from a research into a production tool. So I see this ad for an instrumentation engineer and some really interesting words in there. One of them was cold defamation compression. So what that means is if you use a little bit of physics, right? A little bit of pressure equals volume times temperature, then you can get things to melt by changing pressure and keeping the materials cold. So you never melt them, you simply get them to merge together with physical pressure, not heat energy. So if this doesn't kind of stir some ideas, then you haven't been close enough to this to get ideas stirred. So what this process was is you put some ultra high purity materials into a chamber, and then you warm the chamber and you start flushing it with ultra high purity gases to guarantee that what's in that chamber is as pure a material as you can possibly make it. But you don't want to melt anything. You're just trying to get loose atoms to disassociate bonds and leave the area and get replaced by other inert gas molecules, because we don't want these to interact with what the final product is. So now you've got a whole bunch of whatever your mix is, which would be probably corporate trade secrets somehow. And instead of putting a big bram on one side of it, you flush this material with an inert gas. Now you're even going to take and evacuate that material as much as you can to pull that inert gas off of there. And you might start chilling the material after you've done the final dry to get it to the perfect temperature that you want. And instead of pushing it out of the tube, you suck it out of the tube. So it actually gets drawn out, and using some further techniques, you can align the structures of those materials so that it's a liquid crystal. And now you have some of the most perfect optical wires the industry has ever seen. So I read the fine print, got in contact with them, and they did make an offer. And the offer was about 1/3 of what I was earning. So I said no thank you, because I know I couldn't have kept the family where I was. I would have had a 10-minute drive to work, but it would have been extensive travel after that incubator got started. So who knows where that went? I could go back and look them up. But what was interesting was the cold defamation compression part. Okay, it's a forming technique to make solids out of solids without melting them, so none of the solids would go through a chemical change and change structures into something else. So you've controlled every aspect of the formation of that new material. And like I said, you've invented that one of the best methods to make fiber cables that go across the Atlantic Ocean and big jobs like that. So just fascinating, fascinating. But where was I at this point? At this point, I had been through research organizations and seen samples taken from wells and rocks and seen core samples at this university that were taken for geological exploration as a sidekick to commercial well drilling. So it's a good way to get samples and not have to have your own rig. Then studying a little bit more, so I'm not a geologist, but studying a little bit more about that cold defamation compression and what it can do. Okay, now this was a tool in a machine shop, right? Or in a production area. But salt domes that we walk over, that we drill from, and that we make brine from, many of these are formed that same way because geological time allows for these things. Now you can argue the imaging, whether it's a pimple or something like that, to compare it to, you know, those things that you feel that might pop, or it's a volcano. But there's a lot of analogies you can use to explain how some of these things work if you can understand the time frames that have been allowed for these things to happen. So yes, I do like the idea of a clastic layer. To me, it's a boundary layer between what would be hard earth-borne sediments and the other things that the earth has encountered in its billions of years. Just curious. Peace out.